So once we have the mRNA and it is in the cytoplasm, now it's time to make the protein. So that stage is called translation. So this mRNA is being translated into a protein. So the mRNA, each set of 3 bases equals 1 amino acid. And that equals a codon. So looking at this, so that means AUG is a set of 3, GAC, GCG, UAA, GUA, CGC, UAG. So each one of those is code for a specific amino acid. So each one of these is called a codon. Okay? So those codons, will pair up with anticodons that are on tRNA that ferry in the amino acid. So one tRNA, so if it looks, I don't know, like that or something like that. So the first one would be sorry, is that right? Let me erase that. So the first one would be UAC. And, I'm sorry, UAC. This will look better. And we'll put the amino acid up here. And it's holding methionine. Okay, so the tRNA ferries in methionine, and its anticodon is UAC. Okay, so AUG, this codon up here, is the start codon. And it's always methionine. UGA, UAG, and UAA, these are all stop codons. So once we get to one of those, then the protein is done. So when the mRNA goes into the cytoplasm, it will connect to a small ribosomal subunit. A small ribosomal subunit. And it will connect to it right here. So the first, just put AUG here, GAC, GCG, UAA, GUA, CGC, UGA. Okay, so here we have our This is the mRNA right here. So it will connect with the small ribosomal subunit, and the first anticodon, the first T in our RNA, will ferry in the first to start the protein. This is the start codon, and it goes with the start anticodon, which is UAC. So just do that in another color, UAC. And here's the methionine, and I'm just going to make a ball of it. Okay, that's methionine. Okay, once that starting codon, so the starting anticodon on top of the start codon, so that's the tRNA that brings that in, attaches to that start codon on the mRNA, which is attached to the small ribosomal subunit, then things can start. So once that occurs, it will bind up with a large ribosomal subunit. So large ribosomal subunit. So so that the methionine will be there, and then another tRNA, which will be CUG with some other amino acid, I don't know what that is, but with whatever it is, will come and go next to it. So CUG. And dehydration synthesis will occur, and there will be a peptide bond formed there. Then this tRNA will go away, and the next tRNA with the next anticodon then will come in. So the next one is CGC. So then it will come in. This little amino acid come in, will bind CGC, and a peptide bond will form. And then another one will come in. And the mRNA will continue to go through to match up with these tRNA anticodons. So this one will match, then this one will match, then this one will match, and it will create a protein. Which I should do this all in different colors, but okay. Once we get to here, this is UGA, and what was UGA? It was a stop codon. So stop codon terminates. And what's left is the protein. So once we have this protein, and the protein is going to be, a strand. Getting my colors. So strand. And I'm just going to do it in a couple of different colors to show what this is basically going to look like. See, so it's going to be a strand of amino acids. which is kind of like the primary structure. Once we get that, then it will go into the rough endoplasmic reticulum, so the rough ER, and then that's where it's folded again. It's folded into whatever shape it needs to be in. Some glycoproteins or glycolipids or anything like that are added to it, and for whatever it needs to do its job, and then it is sent to the Golgi apparatus to be processed. So that's how a protein is made. Okay, so this is protein synthesis. And remember, it starts with transcription, so we can get an mRNA, and then the mRNA is translated into the peptide or the protein.